I'm going to explain about FESEM and EDAX. Field Emission Scanning Electron Microscopy FESEM. FESEM stands for Field Emission Scanning Electron Microscopy. It is an advanced type of scanning electron microscope that uses a field emission electron source to provide high resolution imaging of surfaces. Working principle of FESEM. FESEM operates similarly to a conventional scanning electron microscope by using a field emission gun as an electron source. This allows for much higher resolution imaging due to a smaller electron beam spot size and reduced beam divergence. First one, electron beam generation or field emission source. A field emission gun FEG generates a beam of electrons using quantum tunneling instead of thermal emission. This results in a highly coherent and focused beam with low energy dispersion, providing superior resolution. Second, electron beam focusing and scanning. The emitted electrons are accelerated and focused into a fine beam using electromagnetic lenses. The beam is then scanned in a rather pattern across the sample surface by deflector coils. Third one, interaction with the sample. When the electron beam interacts with the sample surface, different types of signals are generated, including secondary electrons SC, which provides detailed topographical information, backscatter electrons BSE, which reveal compositional contrast based on atomic number differences, X-rays, which is used for energy dispersive X-ray spectroscopy to determine the elemental composition. Fourth one, signal detection and image formation. The emitter signals are collected by various detectors which convert them into electronic signals. A computer processes that signals to generate high resolution images of the sample surface structure. Energy Dispersive X-ray Spectroscopy EDAX. EDAX specializes in energy dispersive X-ray spectroscopy, a technique which is used for elemental analysis in material science. It is commonly integrated with scanning electron microscope SEM and transmission electron microscope TEM to analyze the composition of various materials at the microscopic level. Working principle of EDAX. X-ray generation. A high energy electron beam is directed at the sample inside SM or TEM. These electrons collide with atoms in the sample, exciting inner shell electrons, usually in the K, L, M or M shells. The excited electrons are ejected, creating an electron valency in the inner shell. X-ray emission. When an inner shell electron is ejected, an electron from a high energy level fills the vacancy. This transition releases energy in the form of characteristic X-rays unique to each element. X-ray detection and energy analysis. A silicon drift detector SDD or lithium drifted silicon detector captures the emitted X-rays. The detector measures the energy of each X-ray photon and converts it into an electrical signal. The collected X-ray spectrum is analyzed to determine the elements present based on their characteristic peaks. The intensity of each peak correlates with the concentration of the element in the sample. Applications. It is used in material science, forensics, semiconductor industry, biological and medical research. So that's all about FESEM and EDAX. Thank you.